Okay, class, we'll go through the homework for section 18.2. That is your exercise 18.2. Let's start with question number 3. They say to find the velocity of the particle at time t. Now, you are given the acceleration and you are given this information in the question. So A is this, velocity will be integration of this, you will get this. Okay, t is 0, v is 4, you sub in, you get c as 0. Therefore, the velocity expression will be given by this. So that is your part 1. Now for part 2, the displacement of the particle at time t. For displacement, okay, we have to integrate the velocity. So we integrate, we get this. When t is 0, s is 7, so we will get this particular expression as the displacement for the particle. Okay, now next, part 3. What did they say? The greatest velocity of the particle. Now, I already explained in the video previously, greatest v occurs when dv dt is 0, that is when a is 0. So we will equate this, okay, when a is 0. So when a is 0, I put the a expression equals to 0, t is 0, pi, 2 pi, and so on. 0, pi, 2 pi, and so on, according to the sine curve. Okay, now I want you to pay attention here. When t is 0, v is 4. Okay, we substitute here, v is 4. Now we need to do d2v dt square. Okay, substitute t0, we'll get negative 4. Now when this is less than 0, this is a maximum. Okay, now how about when t is pi? When we sub in pi, v is actually negative 4. And d2v dt square is actually 4. When this is positive, this is a minimum. So in order to get the maximum velocity, we will have to use this one. That's the maximum velocity. That is 4 meters per second. Now, some people will say, what if I go to 2 pi, 3 pi, and so on? You will realize that it will oscillate. That means it will go here to here because it's a periodic function. Okay, so the maximum velocity, no matter where is it, is still 4 meters per second. Alright, so that will conclude our question number 3. Next, we move on to question number 5. Okay, first part asks you to find the value of P. Now we know V is this. We know this as given in the question. Velocity is this. Acceleration is differentiation. We plug in, you will get T as 10. Now, when A is 0, part 2, we will get T as 5 over 9. So, V plug in 5 over 9, we will get negative 7 over 9 meter per second. Okay? Now, in part 3, they want us to find the distance travelled in the third second. So, we do the displacement function, we integrate the velocity, we get this particular function here. When t is 2 is 4, when t is 3 is 36. So, the difference is 32. 36 minus 4, 32 meters. So this will be the distance travelled in the third second. So this is question number 5. Okay. Now we move on to question number 6. Okay. Question number 6 asks for the value of t when the particle comes to instantaneous rest. Now when it is at instantaneous rest, that means v is 0. So a is this, we integrate. We sub in, we will get v as this. Okay, we will get v as this. Okay, now I think I wrote the wrong question. Let's move on to question 6 again. Yeah, 6 part 1. Show that the particle reaches P when t is 5 ln 5 over 3. They say the particle comes to instantaneous rest at the point P. Yeah, so at point P, v must be 0. So I put in here v0. Okay, I repeat. Acceleration is given by this. Velocity, you integrate, you get this. This is given in the question. Therefore, we have v as this. Because at P, the particle is at instantaneous rest. Therefore, v is 0. We equate it to 0. We simplify. We take ln on both sides. We simplify. And after that, it will be shown that t is equals to 5 ln 5 over 3. As given in the question. Okay, 5 ln 5 over 3 as given in the question. Now this one you have to use the laws to do it, logarithmic rules to do it. Okay, now part 2, calculate the distance OP. Okay, now we find the displacement function first. Okay, let's find out the displacement function. Okay, displacement function, you integrate, we get this. When t is 0, s is 0, we sub in. So finally, this is the displacement function. So when t is 5 ln 5 over 3, we plug in, we get this answer. So this will be our displacement for part 2. Now for part 3, I need you to pay attention to part 3. The question says, show that the particle is again at O at some instant during the 6th second after passing through O. That means at the 6th second, it will pass through O. Okay, so how do we do that? Now, we plug in. When t is 5, I get this. When t is 6, I get this. Now, can you see that when t is 5 is at positive displacement? When t is 6 is at negative displacement. That means this is the distance, the time from the 5th second to the 6th second. Somewhere between the 5th and the 6th second, it will cross O again. If not, it cannot go from the positive displacement to a negative displacement. So in the 6th second itself, it will have crossed O again. So since displacement is more than 0 when t is 5, displacement is less than 0 when t is 6, sometime in the 6th second, that means at some instant in the 6th second, it crosses O, okay, at some instant during the 6th second. So this is the meaning. Because for it to have positive displacement to negative displacement, it must cross O again. So that's how we explain part 3. Okay. Now for question number 7. Question number 7 is a very standard question. Okay, and it involves trigo. Alright, find the value of t when the particle first comes to instantaneous rest. So you get v is this, put it as 0, do the trig function, divide both sides by cosine t, you get this negative. Now you know negative is either in the 2nd or the 1st quadrant for tangent, but the question says when it first comes, that means it's the first angle, so it's pi minus this, so you get a 2.16. Okay, part 2, the acceleration when t is pi over 4. Now v is this, our acceleration is when you differentiate, you plug in t pi over 4, you will get this answer. Okay, part 3, an expression in terms of t for the displacement of the particle. Now we know that velocity is this, for displacement we integrate. Okay, when t is 0, s is 2, the question told you, we plug in, this will be the displacement function. The distance travelled in the first 3 seconds. Now, the distance travelled in the first 3 seconds is different from the distance travelled in the 3rd second. When we want the distance travelled in the 3rd second, we take distance travelled in the 3rd second minus distance travelled in the 2nd second. That means you must take t2 to t3. But for the distance travelled in the first 3 seconds, we consider everything. Okay, now, all of you look at this particular diagram. It started when t is 0 and the displacement is 2. Then when t is 2.1588, it comes to instantaneous rest, then it turns again. Okay, instantaneous rest means it must turn. So when t is 3, displacement is 6.4. Okay, when t is 2.1588, that means here displacement is 7.6055. Now they want the distance traveled in the first 3 seconds, that means they want like that, like that. So from here to here is 7.6055 minus 2. So this first part. Okay, then you must find this little portion here. How to find this little portion? 7.6055 minus this one, 6.4033. So you get this portion. You add it up, you will get a 6.81 meters. Okay, I repeat. This is t0. When it goes to t equals to 2.1588, it turns until t3. So we must get this distance plus this distance. This distance, you take this value minus this value. This distance, you take this value minus this value. You add them both up, you get the final displacement final distance traveled 6.81 meters. Okay, alright, then we move on to the last question. Alright, now question number 9. It says that we are supposed to find the initial acceleration, displacement of the particle when t equals to 1, and part 3, will the particle return to 0? Explain. Okay, now v is this particular value, a will be you differentiate, you get this, when t is 0, this is the answer. So this is the answer to part 1. Part 2, displacement, we'll integrate velocity. When t is 0, s is 0, we plug in. This is the displacement function. When t is 1, we sub in, we'll get a 9.69 meters. Okay, just be careful with your integration and your differentiation, if not your answers will be wrong. Now, why did the question ask this type of, in this manner, I mean, will the particle return to 0? Okay, now I want everybody to look here. V is 3e 0.4 t plus 6. When t is 0, okay, I will get 3 plus 6. When t is 0 is 3 plus 6, so it's 9. So the initial velocity is actually 9 meters per second when it passes through the starting point. Now, can you see that this particular function here, okay, when t is 0 is already 9. When t is bigger than 0, this one is always bigger than 0. When we plus 6, it's still bigger than 0. That means it is always positive. Always positive. Okay? Therefore, v is never 0. And hence, it will not come to instantaneous rest. That means once the particles start moving, it will go on and on. There's no instantaneous rest, therefore it will not turn back. Okay? That means it will, from the starting point, move on and on and on forever. Okay? Since it does not come to instantaneous rest, it will not return to O. Okay? That means it will travel on forever and ever and will never return to O. Okay? So this is how we explain question 9, part 3. Okay? That's all for section 18.2. Okay? Please make sure you do your necessary corrections and look at the solutions only after you have done your exercise. Thank you.